Good morning. The topic that I choose are vectors. But before that, we need first to be familiar with two things. We need to be familiar with scalar quantities and vector quantities. Scalar quantity is something that has magnitude but no direction. And a vector quantity is something that has both magnitude and direction. Some examples of scalar quantities are temperature, because temperature can be described in its magnitude only. For example, we can say that temperature is 70 degrees, but we cannot say that temperature is 70 degrees going west, because that would be irrelevant. In vector, we have force as an example, because we can describe it both in magnitude and in direction. If we describe it in its magnitude, this example would be like 130 degrees, 130 newtons going west. 130 is its magnitude and west is its direction. So it is a vector quantity. Some more examples of scalar quantities are distance, because it only describes the distance or the measurement, but in vector, displacement is a distance with direction. Because displacement tells us the change in position. And some more scalar quantities are speed, but speed only describes the speed of an object, and mass. So it's only a scalar. And vector quantities are, some of it are velocity, because velocity tells the direction, and acceleration. Acceleration tells us how fast the velocity is changing. And now, let us take a look at an equation. A force vector has a magnitude of 120 newtons directed at an angle of 40 degrees below the x-axis. Calculate the magnitude of the x and y components of this force vector. Express the answer using standard unit vectors. First, we have to write what was described in the equation. And you can see it in the drawing. The F is the 120 newtons, and it is directed at an angle of 40 degrees below x-axis, so it should look like that. And we can put f of x and f of y in it so we can understand it more, and we can describe it as x component, the f of x, and the f of y as the y component, and the theta as the angle theta. We can also use SOHCAHTOA here, which is from trigonometry, and the f of magnitude would be the hypotenuse, the f of x would be the adjacent, and the f of y would be the opposite. So in SOH, S is the sine, O is the opposite, and H is the hypotenuse. So in SOH, it would be sine theta is equals to opposite over hypotenuse. So we can say that from this equation, from this, that the opposite is the fy and the hypotenuse is the f. So we can write it as sine theta is equals to fy over f. And to rearrange the equation, we must multiply both sides by f. And this is what it should look like. The f at the right side of the equation would be cancelled, and then we should get fy is equals to f sine theta. We must remember this equation so we can use this at later on in solving the problem. In CAH, C is the cosine, A is the adjacent, and H is the hypotenuse. So we can say it like cosine theta is equals to fx divided by f magnitude. And to rearrange it, we multiply both sides by f. And f cosine theta is equals to fx divided by f times f. And the f at the right side of the equation would be cancelled out. Then we get f of x is fx is equals to f magnitude cosine theta. In TOA, t is tangent. Tangent theta is equals to fy divided by fx. To rearrange, tangent, arctangent, to rearrange the equation, we must multiply both sides by arctangent. So we have arctangent times tangent theta is equals to arctangent times fy over fx. And then we get theta is equals to arctangent times fy divided by fx. Here, we can also use the right triangle method. And according to the Pythagorean theorem, c squared is equals to a squared plus b squared. If we base from that formula from our problem, if we use this to calculate, we get f squared is equals to fx squared plus fy squared. And we can simplify it, and the answer would be f is equals to square root of fx squared plus fy squared. And now let us continue and solve the problem. First, let us draw a Cartesian plane to plot the given, and this how it should look like. It says that it is 40 degrees below x-axis, so it should be below the positive x-axis and 40 degrees. And then we put the 120 newtons, we plot it, and then let's put the x and y component of the vectors and the angle, which is 40 degrees. So to calculate the magnitude of x and y component of this force vector, we can use the formula fx is equals to f cosine theta and fy is equals to f sine theta. And this is, it would be 120 newtons times cosine theta 40 degrees. So cosine theta 40 degrees would be 0.77, and we would multiply it in 120 newtons, and that the answer should be 91.925 newtons. And at the fy, 120 newtons sine theta 40 degrees, it should be 0.64, and we multiply it in 120 newtons, and the answer should be 77.1345 newtons. And then we are going to express the answer using unit vectors. And a unit vector is a vector that has magnitude of 1. We express using the vectors I, j, k. First, we must draw a three-dimensional coordinate system. And this is how it should look like. I is the unit vector along x-axis. K is unit vector along z-axis. And J is unit vector along z-axis. So we need to know that I is associated with x component, J is associated with y component, and K is associated with z component. To express the answer using standard unit vectors, we can say that F magnitude is equals to the original force vector is equal to 91.925 times the unit vector, because it is the x component, and then plus 77.1345 times j, which tells us the magnitude of y component is 77.1345. So this is one way we can express the force vector. So we can express a force vector or any vector using the magnitude, the angle, or you can express it in component form like this one using the x and y component. Thank you.